Okay, in this video we are going to take a look at making functions continuous. So in our first example here, we have a piecewise function, and we are looking to find the value of a, which shows up right here in one of the pieces, so that this function becomes continuous. Well, what's going on in this, if you were to think about the general graph, this x squared plus x minus 1 is a parabola that's going to open upward, and it's only defined for x values less than 2. So you would have something that has an open circle at the end, and then from there we have a line where 2 is defined. Alright, so perhaps it would look something like that. So we can see that these two pieces do not connect. Alright, so we're looking to find the value of a, and again a represents the slope of this line. We don't know exactly what it is, we're trying to find it. But we want to find it so that it is continuous. So the way we're going to approach this is, again, we need these two pieces to match up. So we need 2 to have the same y value. So because of that, we're going to plug 2 into each piece. Even though in the first piece our 2 is not included, we're still going to plug it in. And we want these pieces to line up, so we are going to set these two pieces equal to one another. I'm going to drop a 2 in for x. Again, even though it's not included in each piece, that's okay. We want these two pieces to line up. So we're putting a 2 in where we see an x, and when we clean this up, we're going to have 5 equals 2 times a plus 3. 2a equals 2, and then a equals 1. So if a were 1, we would see this function become continuous, where the rule is changing here at x equals 2. Alright, let's take a look at another example. So we have another continuous function that's given to us, and we're looking to make it continuous. It's a piecewise function where, notice we have a couple inequalities, but one is not included. Down below here, we're told when x is 1 on this function, the y value is 7. So there's no variable in this anywhere to solve for to make it continuous. Instead, it just says to change the function to make it continuous. So to get a feel for what's happening here, let's graph it. Now we strongly suspect that when x is 1, that's going to be where it's not continuous, since that's where the rule is changing. So let's sketch this. So here's the first piece on our function, 4 minus x. So the y-intercept you can see is 4, the slope is negative 1. It's defined for x values less than 1. Now I plugged 1 into it to get 4 minus 1, which is 3, but I have an open circle there. So notice we have an open circle at 1, 3. The next piece, x squared plus 2. Okay, here's my next piece, x squared plus 2, which is defined for x values greater than 1. So once again, even though 1 is not included, let's plug 1 into that. 1 squared plus 2 is going to give us 3, so notice that is going to start at the same location where the 4 minus x ended. So that's starting right at that hole, right at that open circle. Okay. By the way, this point you see up here at 4, I was just showing you that that's where the y-intercept is. It's not a special point. So our last piece, when x is 1, y is 7. So above this open circle, above that hole, this is where it's defined. That is the point 1 comma 7. Okay. This hole, I'll just jot down, make that a little more clear, that is 1 comma 3. So we can see that this function is not continuous because at x equals 1 we have a hole. Now make note that this is a removable discontinuity. So this is a removable discontinuity because we can think of it as fill that hole. So in other words, if I were to change this 7 to a 3, then this point up here would come down, it would fill that hole, and therefore make it continuous. So A removable discontinuity, we said that happens when we have holes. Yes, we said holes are created by common factors, and the idea of canceling out and removing your common factors, well, you could also think of it as it's removable because it could be filled in, all right, by changing the y value. Okay, so if we were to change that 7 to a 3, that would force this function to become continuous.